Alrighty, I'm back. So I'm back to work on the INI API for my game engine. Actually, as it happens, I got quite a lot of work done since the last stream. When I last left off, I had been in the middle of overhauling the file, or the INI reader API, so the API by which you get data from an INI file. And I came up with a couple things. First, let's go ahead and start with what the API does. So I'm running a quick little build. Any second now. Come on. There it goes. There's not really a lot going on in this one. We've just got Madeline with a cube. This is not like a scene renderer yet. The scene serialization is ready to go, and so is the API for creating systems for the ECS, but that's not what the focus of today is. Instead, it's the process of loading and saving data to INI files. And I already use it for input. For example, I pretty much always have escape on the keyboard set up for closing the program. So if I press escape now, it'll quit. But that's actually set by a data file. That's not hard-coded. If I go to the project folder here, I actually created an INI file for mapping all the input. So the key that I'm taking advantage of here is this one, action mapping. It maps the keyboard escape key to the exit action, and then I listen for the exit action when running the game. And you might see that I've also got mappings for Gamepads down here. So no matter which kind of controller you're using, if you just listen for exit, then it'll pay attention. So like even now, if I was to turn on my Xbox gamepad here, the back button is mapped to exit, so that works right off the bat. But there was some problems with the API, and one of the things that one of the cool features that I needed to have, but didn't have a mechanism for it yet, without being able to use text file writer to write text files or move them around, is that now I have the ability to have a working copy. So as it is, if I was to delete the data folder, which is the temporary location for user data, overridden to that location by the command line arguments here. I made the engine accept this command line argument data dir to redirect it. When I run the program, it's not actually loading the INI file from the content. What it's doing is it's trying to load it from the data directory. And if it doesn't find it, it copies in the file from the content directory. So if I go to user data now, you'll see that I've got testinput.ini. It's actually the same file, but this is an important distinction. This file is editable without affecting the golden copy of the file. So the file that ships with a game, for example, a basic settings file, a basic INI, containing generic stuff that would apply to everybody, and it contains all the default values, that can be unmodified. And then automatically, by virtue of the API, when you go to use the INI file, it will automatically handle putting it in a good location. So if I was to go into here and change up the control for escape, for example, right now I've got it to the gamepad options button, which is the what used to be called the back button on the Xbox 360. If I change that to menu, which I believe is the name of the start button now, we hit Control S and save, and then I restart the app. Now, if I press the back button, nothing happens because it's not paying attention to to the back button anymore. It's paying attention to the menu button. So if I press the menu button, then it closes. Here's the cool thing about the change in the API, is that now, if the user was, for example, writing, like going in and tweaking their own INI files, like if they were, trying to mod the game, or just to change settings that aren't normally exposed through the editor, power user stuff, and then they screw up, they can just delete the file, and then the next time the game runs, it'll just regenerate the file from the original directory. And you can see here that when I reopen it, this is the wrong file. When I go to reopen it, the options button is again set as the back, because it copied it from the content directory, which has the known good copy. Now you can see that the options button does that again. So let's show how that works real quick. The input system has its own function called load context file. So when you are working in your game code, you normally aren't directly loading an INI file to load input contexts. Instead, you just point to an INI file that contains them. And in this case, that call is right here. So there's a lot of stuff going on here. That's like all of this is actually just for testing the writer, which I did a couple of streams ago. Close that out. And that's actually if we look back at the user data folder, that's what this is, test INI write. It's being generated by this test. The first thing I do when I initialize my base game state is I load a context file. So I tell it that I want to load some input data, so input mapping data, into the engine so that I can start using those actions and axes. And the API has two paths. It takes two paths in the call. The first is the one that you actually want to use. So this is actually going to be the path to the data folder where you want the user's copy of the settings to be. The second one is the backup path, or the fallback path. So the idea is that you tell the game where you want to read the data from, but if the file doesn't exist there, so for example, if they're launching the game for the first time on this computer, or if the file was deleted because the person deleted the file to regenerate it, or if they're like on a new Windows account that wasn't on the computer before, then the INI API will realize that the file doesn't exist and then copy it in from this location. And if we look at the under the hood, basically that's just done with the INI reader API. So load context file, you call it, and then it basically just loads an INI file using the INI reader API, and then parses it for the information that it wants. But the file name and fallback mechanism, that's built into the API. That's what I just was working on. So that's working great. I've got the API working to the point where it's covering all the needs of before. It's doing it a little bit better though, but there's still a few things that I need to work out. My current project is dealing with the data type that you get when you retrieve data. So one of the harder things to work out for how to work with this API, how to make it elegant but useful, but powerful, was how to handle these kinds of values. So this is something called a dictionary value. That's not a normal part of INI files. That's an extension that I built into my engine. The idea is that instead of just having to assign for every INI key, assign one INI value, you can actually assign, if you use parentheses, you can assign a bunch of key value pairs. And that's handy for inputs. This is actually the main reason why I designed dictionary values. It's handy for the input system specifically because it allows you to put a lot of data in one line for specific entries. So I can, in a single line, say what the name of the axis is, what control it should be using, and what scale factor to apply to it. So in this basic example for that we're looking at here, we have the ASWD keys, which when you're working with video game characters, you're not thinking in terms of ASWD. You're thinking in terms of what input vector do I need to respond to. So the player is telling the character to go a certain direction, and then you just deal with those axes without thinking about whether you're using the gamepad thumbstick or the keyboard keys. But they need to be mapped to the same axis. So I've got two keys pointing for name equals move x, name equals move x. The A and D keys, which are on opposite sides of the x movement, but I have a scale factor of -1 applied to A. So when you press A, it subtracts a value of 1 from the axis, and if you press D, it adds a value of 1 because its scale is 1. And if I'm remembering right, scale is actually even optional. Like I might be able to clear that and have it just work, but when you serialize the stuff, it'll be explicit. But in order to make something like that work, the problem was that you don't know what type the data is. There could be different kinds of data. For example, for the axis mapping, you've got a string for the name, a string for the control, but a floating point value for the scale. And so I came up with the idea that I could return, when you go to query for the dictionary, you can get a map back, mapping the hash name of the subkey. So that would be, heading back to this, that would be the hash name of this guy, the subkey, and then get back, or sorry, not that guy, this guy, name equals, that's the subkey, and then get back the value, the sub value move x in whatever type you want. And that's done by using a type called ini value t, which is a wrapper for an STD variant. And something that I did off stream, like I did this about an hour ago, and it's kind of an awesome deal, but I've got to work on it a little bit today. The ini value t now is a struct. The reason why I did that is because back when it was simply a type def, you had to use std get everywhere. So you had to do std get short or std get 0 or whatever. And that wound up being a little awkward to write. For example, coming back to this guy, there was a here we go. Whenever we go to write these values, so getting a value out of the map that was returned by the INI, by the dictionary value, it was a little bit hard to write. You used to have to do std get, say the type that you want, and then wrap that, and that would get you, that would do a return value of whatever it was you were doing. That was that doesn't work anymore because I've now wrapped it inside of a struct. But you get the idea. Like that was kind of wordy, with the operation as I have it now, and I'll show another example for the floats. Like here, float scale converted. Now you can just access the map, and because the return value is that struct with the helper operators automatically convert it to the type you need. So in this case, it's returning the enterprise ini value t, which is the wrapper for the STD variant. So this could be one of any of the types supported by INIs. And then by merit that I'm assigning it to a float, the correct constructor is automatically called. And if we take a look again at the constructors I got here, it will automatically invoke this constructor where it converts into a float. Or technically it's a conversion operator. Sorry, I'm using the wrong terms. Then what it would do is it would automatically call the correct variant of stdget and then convert it for you. And that's done invisibly. You just use the value in place where you would want to use it, and it automatically converts. There's still a couple of problems to work out on that front, and that's what I'm going to spend the rest of tonight doing. It's working that stuff out. But it works pretty good right off the bat. The first thing that I need to worry about is casting to the wrong type. STD variant, if you do a cast to the type that's not actually inside the variant, will throw an exception, and that will crash the program, and that's, bad news bears. But if we go back to where was I working? It was underneath, not the INI reader, the input controls. There was a case where the operators where the conversion operators aren't perfect. In this case, the reason why I have to do dot operator is because the macro that I'm plugging this into, where it's actually a wrapper for a function, it will accept both a C string and an STD string, and there's a constructor for both. So it's not easy to determine by the compiler which one of these I'm trying to use. HN for hashing strings can accept either a C string or a C++ string, and I can convert the INI value type to either a C++ string or a C string. So in this case, what I had to do is actually explicitly call the operator. I think I'm going to need to come up with a better way than this in a little bit, but for now I'll do operator std string. I call that, and then it works like a charm. It hashes the name and so on and so forth. But something, as soon as I demonstrated that it works, as soon as the build catches up, I'm going to use the other operator, the operator for the const car pointer, and show that if I accidentally pick the wrong operator, then it will crash. And this could happen a lot more simply as well. If I was to try and cast to a double, for example, it wouldn't necessarily figure out that I am trying to get back the float. It would try and get back a double, but the STD variant knows that it's not a double, and it'll throw an exception. What is taking so long with the build? I changed one thing, I'm pretty sure. Oh, come on, you're killing me, Visual Studio. Seems to be stuck on something. Let's cancel the build. Oh, no, it's making progress now. It says I know, reader.cpp. There we go. Wow, this is taking a long time. One consequence of working on this kind of code is that it is far-reaching. This is in the header for my file system, and that's used in quite a lot of places to read and write data. Oh geez, this is taking forever. at some point I want to go through and help clear out these compiler warnings they've been piling up. Most of these aren't even from my project. Most of these are actually from, well, this one that I'm looking at is from this project, but most of the warnings that I've come across come from my sub project, Hot Constants, and a couple from STB image. Oh my gosh, come on. Is there something else bogging me down? Like I've compiled fine with OBS before. I'm sure it's not the fact that I've got OBS open. But you know what? Maybe it is. Maybe it is because of OBS. Something that I've done differently this stream is that I've actually went ahead and installed the VST2 versions of my audio repair suite, and so I'm running my voice through the Isotope denoise plugin, and I'm wondering if that might be just going a little hard on my computer. That might be a problem. If this is going to be the case, that it's going to slow down my builds this much, then yeah, I'm going to need to do something different. Let me make sure my fan's all the way up. Let's try that again. I'm wondering if reattempting the operation does the same thing. Holy cow. Build, cancel build. Yeah, there's no way that this is taking that long to compile. Like normally it's just like a few seconds. I'm going to run a test. I'm going to turn off the denoise, so you might get a little bit more fan noise than before. But let's try building now. Maybe there's maybe it's not enough to turn off the filter. Maybe I need to actually remove it. I'll turn off denoise. All right, now it's actually out of the chain. Come on. It's even taking forever to cancel now. Oh my god. Okay. Clean the solution out. Wow, it's taking a huge amount of time to clean as well. Let me close out and relaunch Visual Studio. Maybe that's part of the problem. And in the meantime, I'll turn that filter back on. Yep, wrong one.